Sir. Okay. Students, this is chemistry 18th class. In the carbohydrates, we are going to explain the structure of galactose, you see. So, galactose is a monosaccharide, of course. Galactose is a monosaccharide. It is a reducing monosaccharide and it is formed in the hydrolysis of lactose, you see. Hydrolysis of what? Lactose. Lactose means C12, H22, O11. Glucose, that is sucrose, maltose, lactose. So, when lactose is subjected to hydrolysis, that is H2O, you will be getting C6H12O6 plus C6H12O6. So this lactose is nothing but one is glucose, second one is galactose. Galactose. So therefore, galactose is a monosaccharide, that is reducing monosaccharide, which is formed during the hydrolysis of lactose. When lactose is hydrolyzed, you will be getting glucose and what? Galactose. So structure of galactose is nothing but the structure of galactose is similar to that of the structure of glucose, you see. How actually? But there is a change in the H and OH groups at the fourth carbon atom. So let me write the our structure of glucose, you see. So that is our structure of glucose. That is so 1, 2, 3, 4, 5. So structure of open chain structure of that is galactose we can write. So that is 1, 2, 3, 4, 5, 6. That is CH2OH. Fifth is OH. So this is double bond O, single bond H. From this OH, this is H, this is OH, and this is hydrogen atom. This is OH, and this is H, and this is H. This is a glucose structure. But for galactose, you see 1, 2, 3, 4, fourth carbon atom. There is an interchange of H and OH. You see, therefore it is H. This is OH. This is galactose, of course. So alpha D galactose, beta D galactose. So for example, this is O, this is H. So this is alpha D galactose. Now, so this alpha D galactose can be written in this form, you see. That is 1, 2, 3, 4, 5, 6. You see. First carbon on right hand side, OH is here. This is hydrogen atom. Second carbon atom, OH, and this is hydrogen atom. Third carbon atom, this is H. Right hand side below. This is OH. So fourth right hand side H, this is OH, and now it is H and this is CH2OH. So this is alpha D, that is galactopyranose, you see. Alpha D galactopyranose thing. Beta D means H and OH are interchanged, that's all. So this is the structure for galactose. Now this is also one monosaccharide, of course, in addition to the glucose, fructose and glucose and fructose. Now I am going to switch on to the another topic, which is disaccharides. Disaccharides now. Disaccharides. So we know that, you see, disaccharides are nothing but the carbohydrates which on hydrolysis use two monosaccharide base. So examples are, that is maltose, and then lactose, and then sucrose. These are the disaccharides. We are finishing the there is monosaccharides, glucose, fructose, galactose. So now disaccharides, maltose, lactose, sucrose. We know that, you see, maltose is called the malt sugar, lactose is called the milk sugar, sucrose is called the cane sugar. So now I am going to take the first one is maltose, you see, that is maltose. So this maltose is also called malt sugar. Since it is obtained by the hydrolysis of starch by the enzyme diastase present in the malt, you see. So for example, what is the formula for starch? C6H10O5 n times plus H2O. You will be getting, that is C6H12O6 n times of C6H12O6. So that means that this is the starch. This starch undergoes hydrolysis by the enzyme diastase, you see, diastase present in the malt. So therefore it is called the malt sugar. That is maltose is also called the malt sugar because it is obtained by the hydrolysis of starch in presence of an enzyme diastase present in the malt. So now that is Haworth structure for maltose, you see. How this maltose structure is obtained? maltose structure is obtained by the condensation of 2 alpha D glucosinates. 2 alpha D glucosinates means take 1 alpha D glucosinate, another alpha D glucosinate, undergoes condensation between C1 to C4. That means you see carbon atom 1 of 1 glucosinate is linked with the carbon atom of 2 second carbon atom of the second glucose molecule through an oxygen atom. That means 2 monosaccharides are linked through one oxygen atom. That is called the glycosidic linkage. That is called the what? Glycosidic linkage. I am going to write the structure for maltose here. You see. Just here. That means you see maltose is obtained by the condensation of C1 of alpha D glucose linked with the C4 of another C1 of alpha D glucosinate with C4 of another glucose. Both are alpha D. That is C1 of alpha D glucose linked with the C4 of another alpha D glucosinate. I am going to write 2 alpha D glucosides. That is our structure here. You see, just here. So that is this is oxygen atom, of course. This is one. Again, this is 1, 2, 3, 4, 5, 6, and it is 1, 2, 3, 4, 5. Now you see that is alpha D means you see. So alpha D, that is this is OH, this is H, this is OH, this is H, OH, H, CH2. You see, if you write the that is structure for many number of times, we can easily write this structure. You see. Let me write how actually it will be. Cl 1, 2, 3, 4, 5, 6 CH2OH. Here this is OH. This double bond was in the bond H. You see. So this is OH. This is H. This is what? OH. This is H. So this is OH. This is H. And this is also what? H. Now our structure, ring structure is this is O and this is H and link is like this. This is alpha D glucose of the alpha D. Carbon atom 1 OH is here. You see OH. This is H. Second carbon atom OH again here. Third carbon atom H here. OH is here. Fourth carbon atom OH is here. H is there. H CH2OH. So that means you see this is how we can write the our structure easily. Again alpha D glucosinate again one more. But write the same thing you see. OH, this is H, this is OH, this is H, OH, H and CH2OH. So this is alpha D Cl. This is alpha D plus glucose. This is also alpha D plus glucose. But both are internally linked with one oxygen atom. You see how actually you see Cl. This is OH. This is OH. Remove this OH and this H. OH and this H is H2O. Between which one is linked? Oxygen atom. You see OH is here. One OH and another hydrogen atom H2O. And therefore you are going to link this these two monosaccharides with one oxygen atom. Therefore it is called the glycosidic linkage. It is called the glycosidic linkage. Linkage. And the whole thing is called the maltose. This structure is called the maltose. It is the maltose. That means it is alpha D glucose. It is alpha D glucose. The whole thing is called the what? Maltose. So of course, if you ask for it is alpha D maltose, alpha maltose. If we ask for beta D, you have to interchange the OH group at the first one. You see, this OH is there, not here, only here. Understand? This is called the alpha. That is the maltose structure. Maltose is the disaccharide which is formed by the combination of or condensation of C1 of alpha D glucose unit with the C4 of another alpha D glucose unit. Both are alpha D linked through one oxygen atom. Okay, so this is that is a maltose structure. So coming to the another one, that is called what? Lactose. Now, lactose is also called the milk sugar, you see. Lactose is also called the what? Milk sugar. Because it is abundantly present in milk, you see. Lactogen bottles are there, you see. It is added with milk. So therefore you see, lactose is a disaccharide. It is a reducing disaccharide, and it is obtained by the combination of one beta D glucose with beta D galactose, you see. Yes, here beta D galactose plus beta D glucose. Yes, here lactose is a milk sugar. It is made up of two monosaccharides. One is beta D galactose, another one is beta D glucose. Both are beta beta. It is both are alpha alpha maltose. It is beta D galactose, beta D glucose. But remember, in the beta D glucose, C1 of beta D glucose is linked with C4 of beta D glucose. C1 of galactose is linked with the C4 of what? Glucose. Okay. So this is how you can link here. So now you have to write the hour structure for this. Now, so we know that, you see, what is the difference between glucose and galactose? Glucose and galactose structures are same, but the structure of galactose is the structure of glucose is similar to that of the galactose, but only differs at the fourth carbon atom. Only differs at the what? Fourth carbon atom. That means you have to interchange write the glucose structure as it is. At the fourth carbon atom, you interchange the H and OH group. Then you will be getting the galactose. How is galactose is obtained? You write the glucose structure as it is, and then you interchange the H and OH group at the fifth, that is the fourth carbon atom. You will be getting galactose. So that means rearrangement of H and OH groups at the fourth carbon atom of glucose gives the galactose structure. That's how. So that is I am going to write again, you see. So of course it can be written like this, you see. So this is let me write again. Once again I am going to write the structure. So that is our structure. See here. Galactose first I am going to write. This is galactose. See here. So first let us write the glucose. Okay, and then you can change it to what? Galactose. So glucose means, you see, that is alpha D glucose means here, you see. So this is OH, but we want beta D forms, you see. Therefore OH should be here. That is, this is OH and it is what? So therefore beta D means, you see. So this is OH and this is H, and then this is OH, this is H, this is H, this is OH, this is OH, this is H and CH2. It is beta Cl. It is beta D glucose. It is beta D glucose. So write the beta D glucose again, one more. Okay. So that is here OH and this is H. This is OH. This is H. This is H. OH. OH. H. H and what? CH2. Cl 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 5, 6, of course. Now you see, it is glucose actually, beta D glucose. It is beta D glucose. Here, it is beta D glucose. It should be glucose. It is beta D glucose, but it is converted galactose just by changing the H and OH at the fourth carbon atom. Okay, beta D glucose is converted to beta D galactose just by converting the H and OH groups at the fourth carbon atom. So therefore it is H and this is what? OH. Now it is beta D galactose. Beta D what? Galactose. It is beta D glucose. Now C1 to C4, you link the C1 to what? C4. C1 is here, C4 is here, you see. So therefore, OH to H remove, H2O. In between, which one is comes? Oxygen atom, this oxygen atom. Okay? So therefore, it is like this, you see. Oxygen atom is in between the two. So it is like to be N-shaped, you see. Okay, N-shaped. And this structure is, this is beta D galactose, beta D glucose. The whole thing is called as your lactose, structure of lactose. Okay, so this is the structure of lactose, which is called what? Milk sugar. Okay, that is maltose, lactose. One more is sucrose is there, you see. First one. Actually, sucrose. But sucrose, you see, the structure of the sucrose is a disaccharide. Of course, it is a non-reducing disaccharide. Not reducing, it is what? Non-reducing. It does not contain either aldehyde group or what? Ketonic group. So for this reason, you see, that is sucrose. That is C12, H22, O11. Sucrose is a non-reducing disaccharide. Non-reducing what? Disaccharide. And it contains, it is made up of alpha D glucose with beta D fructose. Alpha D glucose, beta D what? Fructose. That means alpha D glucopyranose with beta D fructopyranose ring. Okay. Where C1 is linked with C2, not C4. Remember, C1 of alpha D glucose linked with C2 what? Beta D fructose. So therefore, when C1 of alpha D glucose is linked with C2 of beta D fructose, then it is confirmed that you see that at the C1 of alpha D glucose, aldehyde group is there. At C2 of beta D fructose, ketonic group is there. You see. Both will vanish. So for this reason, so that means the resulting molecule does not contain either aldehyde group or what? Ketonic group. Hence it is a non-reducing disaccharide. It is a what? Non-reducing disaccharide. It does not reduce Stolz reagent at what? Filling solution. That is how we can explain the that is structure of sucrose. Now we can write the that is Haworth structure for what? Sucrose. So that is alpha D glucose, you see, we can write alpha D glucose like this. Alpha D glucose, this is alpha D glucose. It is 1, 2, 3, 4, 5, 6. It is 1 I suppose. 1, 2, 3, 4, 5, 6. From this side I am going to write this side. This is 1, 1, 2, 3, 4, 5, and then what? 6. Okay. Alpha D means, you see, this is OH, this is OH, this is H, this is OH, H, H, OH, OH, H, H, and what? CH2, OH. Tell the groups here again. It is CH2, OH, it is H, OH, it is H, this is OH, this is OH, this is H, this is CH2OH, this is what? H. And you have to link these two. You buy that is H2O and you will be getting O in between. Okay. So therefore you see this is alpha D glucose, alpha D glucose. This is what? Beta D fructose. So and the total is this is sucrose. It is a sucrose molecule. Sucrose molecule. And this sucrose molecule does not contain either aldehyde group or what? Ketone group. So therefore it is a non-reducing disaccharide. It is what? Non-reducing disaccharide. Okay. So this completes the disaccharides. Okay.